Hello and welcome to our session on how to secure U2 DataServer Communication using SSL. Once again, I'm your speaker, Mike Belmy. Some suggested resources to follow along with the demos here. Our U2 Certificate Management tool that's found within the U2 Common Clients version 5.2.1. That's a free download from our product matrix. The Secure Uni RPCD, that's found in Unidata, going to be Unidata 8.2.2 and Universe 12.1.2, though it is out in some of the late 8.2.1 Unidata hotfix releases. Most importantly for this demo, I'd suggest downloading the U2 DB Tools version 4.4.1 preferred, though really 4.4.0 and up would probably do fine. Again, that's free from our product matrix, and we have a few other links there to the Rocket MVU GitHub. So just getting right into this, there's not much for PowerPoints here in this presentation. This is mostly just going to be a demo of how to apply SSL to your U2 server. We're going to set up SSL for incoming connections. Basically, the four main steps are outlined there. We're going to create this certificate signing request, create our own self-signed certificate in this demo for use with the server, and then we'll go ahead and create a security context record in the U2 database, and we'll use that security context record to then configure our services for SSL. Okay, to start off here I have, let's see, xadmin up and running. I have xadmin 4.14.1, which is the latest from the 4.4.1 U2 DB Tools package. I have a local install of Universe I'm going to be working with to set up SSL here. So I've already added the server into xadmin here. We're going to connect. I'd suggest connecting with root or some sort of administrative account for the server side, just because most of the tasks we're going to be doing here do require administrative privileges, at least in the database. So once you're connected to the server, we'll scroll down in the admin task to SSL configuration and double click that. Basically, we're going to work from left to right across these tabs here. First one is create a certificate signing request. So we'll click this button here. I'm going to skip through most of these windows like this. So essentially the first thing it's asking for is for you to give a path to a certificate signing request file that you want to create. So this is a file not yet created. I'm going to browse here. I have a certs directory already created on this machine. And test2 is where we're going to be. Let me bring this into the window here. Test2 is where I'm going to be creating everything. So though it's asking for directory here, it actually wants directory and then the end file name. So we'll give this testcert.csr, and I'm just naming that for certificate signing request. You can put any extension you want on the actual file name created. I'm also going to copy this part into my clipboard because I'm going to be reusing that in a minute. This is just a digest algorithm for the signing request, not the actual certificate. When we get to creating the actual certificate, there will be more options like SHA-2 and such. So we'll go ahead with next. Though these are optional, I suggest filling them out each time. This is what actually goes on to the certificate you're going to create. And the common name is probably the most important. You should be putting the fully qualified domain name of the U2 server. So in that case, it's my machine name .rocketsoftware.com, so the machine name followed by domain, fully qualified domain name. This goes on the certificate as well, so if you don't want your own email, then I'd make something up. We're going to be generating a new key pair for this test. So next. Again, this is asking for files you're going to be creating, so a private key file to create. And that's where what I copied into my clipboard will come in handy. You can just paste it here, and we'll just give them different extension names in that test2 directory to differentiate. So this one's private key. Let me below there. Click OK. And I'm actually just going to paste this in here, name it .pub. So these should all be created within this test2 directory. Normally I use Rsa Keys. It's pretty standard. 2048 is a good length. There's more options though if you need something a little heavier duty. I like to use PEM, though we support DER format or DIR as well. So this is a password to create on your private key, since it is an encrypted private key. And if all goes well, it should be generated successfully. And I can bring up that directory in Windows Explorer here, and we'll see we have the signing request, the public key, and the private key. Just to give you a look at those real quick. That's what it all looks like when it's in the PEM format. It's human readable. And I'll show you the private key real quick too. So again, human readable. Next step after we have the signing request and keys, like I said, work your way left to right. So certificate, generate a certificate. This is only going to be done if you're creating a self-signed certificate. If you're sending your signing request off to a certificate authority to get back a real CA signed certificate, then you'd skip this step because they create the certificate for you. So next, again, a file we're creating. And this one's going to be the actual certificate file. Windows recognizes CRT and CER extensions as certificates. So if you're on another OS, Unix or Linux, really the extension won't matter too much beyond just identifying it for yourself. Signing request file. This is the one we already created, so we'll go ahead and select that. Next, this is how long your certificate will be valid for. We'll just give it 10 years here. And in this case, I'm creating just a self-signed root. If you already have a root certificate and you're signing off say a server certificate or intermediate certificate, then you'd select one of those other options. This is where you select the signing algorithm for the actual certificate. And like I said, there's the additional options that show up. SHA-256 or anything in the SHA-2 family is pretty much the standard today. Again, we select our private key file we already created. And enter the password that we put on that already. Generated successfully. Now we do have our certificate in that directory here. Yeah, that's what it looks like. If you go to details, the subject, that's where all those details go. It's just self-signed, so nothing else in the chain. Next step is where we actually do something within the database. This is create a security context record, which goes ahead and links that certificate to the database and the SSL server you're creating. So first you select a database account. I'm going to do HS sales, though this really doesn't matter. This is just purely an account to store the security context record, which will be a record, well, inside an OS level directory file it'll create. I'll show you that in a second. Often I'd suggest avoiding the UV account just because that may get wiped out during upgrades on occasion. Just watch out during an upgrade. If it goes missing, you may have to recreate a security context or pull it in from backup. I already have quite a few here. We're just going to add to that list, so create a new one. And give it a record ID, so we'll do new test 1. And I'd suggest clicking this double arrow down for the extended version. This is how you can put a range on the protocols allowed. So this, a minimum of TLS v1, maximum of 1.2, so anything in that range will be allowed. I wouldn't suggest anything below that. TLS v1, that's really there for really old clients that don't support anything newer. TLS v1 is itself relatively old compared to 1.1 and 1.2. So if you need some sort of backwards support, I'd suggest a range like this, though there's other options you can do. If you only want TLS 1.2 allowed, that's fine too. I'm going to do a range though. We're doing this for server setup. Screens like this I'm just going to leave as the default. If you have a certain authentication depth, or if you have client authentication you want to turn on, you can do that here. I'm not doing anything with certificate path rule. We do need to add the server certificate file now. That's the one we just created. So test2 testcert.cer, and I'm clicking OK just out of the window here. It's PEM format. Now we select the private key that went with that, so our .pvt file, and enter the password we set on that. Again, that's PEM format. Next. Nothing here, this is optional. Again, optional, this will actually be created automatically. Optional. Optional. And now we add a password to the actual security context record, since this is an encrypted record in the database. So it can be the same password as your private key. It doesn't have to be though. You'd probably be more secure if they were different passwords. Okay, looks like that was added. We see it listed here in this account. I actually have a TCL session open in the database. I've already logged to HS sales. So what we're going to do here is list ampersand SECUCTX ampersand. I think for Unidata that's underscores rather than ampersands. That's about the only difference. And we see it's broken into 2 lines, but we see I have 7 records in there, and that's the one I just created. So that's where that's stored at the OS level. I can show you also in Windows Explorer real quick. U2, UV, HS sales. It's a directory. So once you have a security context record, next step, just move to server configuration. So this file is actually shared with Unidata. That's why I have something here. This is set or saved in a file in the Uni shared directory. We're still setting up Universe in this case, so I'm going to do UVCS service and UV telnet D, and then we'll test out the UV telnet D real quick just to make sure that's working after we set this up. I'll show you where this is creating a file on the server side I mentioned in Uni shared. So if we go to U2 Uni shared, It's actually this .unisecurity file here is where this is all being saved. And if you encrypt it, then that file will be encrypted. If you choose to leave it unencrypted, you will have the password shown saved in there in clear text. So just be aware of that. You can, I believe, tag it for a machine as well, so that it can't be moved to other machines and used. So we'll go ahead and click Add. Here you select the service name that you want to secure. We'll do UV Telnet-D to start. Select the database account where you saved your SCR you want, and select your SCR you created and the password you added on that. That's the SCR password. There we go. UV Telnet-D is secured now. Let's add one more service, though I'm only going to show you testing UV Telnet-D just to keep this short. Same thing, just a different service selected. Okay, and just to show you here, this is a Windows only thing, the Telnet service. So you can disable the unsecured Telnet port if you want, or leave them both up. The SSL Telnet port 992 is the standard there. I'm going to leave that. And we should see this banner if we successfully get to that endpoint with SSL. I'm going to test it actually using OpenSSL, which works for just the UV Telnet-D since that 992 port is listening. If we tried to connect directly from OpenSSL to the UVCS service that goes through the UniRPCD on port 31438, yeah, that wouldn't go well communicating with OpenSSL directly. You need some sort of UO.NET client with SSL to be able to test that. So the bin directory has OpenSSL installed for Universe. That's the version. So what I'm going to run to test that is actually an OpenSSL s_client utility. So OpenSSL s_client -connect, and then we give it the same name we had on the certificate, the machine name, fully qualified domain name, and then our port we're trying to communicate with. And I like to add this show certs option so that we see a copy of the certificate come back. Enter, and we're looking good. If we go up to the top here of the output, we see some of the certificate details from what I created. The actual certificate copy comes back. We see that it negotiated TLS v1.2 and is connected here. And we did get our login prompt. Yeah, so that's looking good. We know the SSL server set up correctly, so UVCS should also be secured. I'm not going to show that in this demo, so I think we're about done here.